Well, I thought I would go ahead and do a few examples of some word problems using law of sines. So this first one is number 31 in your textbook. The path of a satellite orbiting the Earth causes the satellite to pass directly over two tracking stations, A and B, which are 50 miles apart. When the satellite is on one side of the two stations, the angles of elevation at A and B are measured to be 87 degrees and 84.2 degrees, respectively. How far is the satellite from station A? Now, on this one, you have a picture. But what I recommend that you do with the picture is redraw it using so that you can see the triangle without all the extra stuff in the picture. So we're trying to find how far the satellite is from station A. So this is what we're told. So I have all this information in. I want to find the satellite from station A, so I'm looking for this distance I'm going to call D. Now, you got to use a little bit of geometry. So for example, if I know that this angle is 87 degrees, then I also can figure out this. So this angle here is going to be 180 minus 87 degrees, so we get 93 degrees. So I'm going to put that here. Well, if I know this is 93 degrees and I know this is 84.2 degrees, then I can figure out the missing angle. So 177.2, so this is a very small, oops, wrong symbol there. So we get 2.8 degrees, so this little one up here, so obviously not drawn to scale. So that's 2.8 degrees. Now, I'm trying to find D. I have a triangle. This is not a right triangle, okay, so I can't use SOHCAHTOA. I'm using the law of sines. Now I have an angle on its opposite side and an angle, and I'm looking for D. So I can have sine of 2.8 over 50 equals sine of 84.2 over D. So to find D, I'm going to multiply 50 times sine 84.2, and then I'll be dividing by sine 2.8. I am fine with this amount of work. Like if you just show me the proportion and then use your calculator to work it out, that's fine with me. That's enough work. Well, with a picture and all that. I mean, you don't have to go through and show me all the steps of solving the equation. So we get approximately 1018.3, and that is miles. So that's the distance from that satellite. There is a part B to this one, and part B says, how high is the satellite above the ground? Okay, well, here's my satellite. So I actually have a new triangle this time. I'm going to see if I can kind of draw this in. If I draw just a vertical line right here, because the height the satellite is above the ground has to form a right angle with the ground. So I've got this triangle, and now I'm going to redraw the triangle. So I've got this is my distance above the ground, which, okay, so here's my picture. So how high is the satellite above the ground? All right, so I'm going to call this H right here. This is a right angle. And what else do we know? This little part right here is comparable to this little part right here. So if this that I have marked as 93, and then we have that straight angle, this has to be 87 degrees here. And what else do we know? We know that this side right here, this was the satellite, and this was station A. And we just found this side to be 1018.3 miles. So now, note, this is a right triangle. I can just use SOHCAHTOA. So I can say sine of 87 degrees equals opposite, which is H, over hypotenuse, which means I just multiply sine 87 times this number here, which I already have that number in here. So I'm going to multiply by sine 87. And I get that H is about 1016.9 miles. And that would be my answer to part B. So again, separating out these triangles from the picture, drawing an additional triangle, using geometry and figuring out some things with angles, but I would expect to see pictures on these types of problems. Okay, number 35 is another example. The Leaning Tower of Pisa. The bell tower of the cathedral in Pisa, Italy, leans 5.6 degrees from the vertical. So I've drawn in black a vertical line, and then this blue line here represents the Leaning Tower, and it's 5.6 degrees from vertical. A tourist stands 105 meters from its base. So I'm going to let that be this part here. So here's my tourist. So this is standing from its base. And she measures the angle of elevation to the top of the tower to be 29.2 degrees. So I'm going to mark this drawing in that part of the triangle. And this is the angle of elevation. Remember, angle of elevation is always measured from the horizontal, but that would be this. So 29.2 degrees. This is the top of the tower. Okay? And we need to find the length of the tower. So that's this leaning part. So I'm just going to put a L, and I like to do it cursive so it doesn't look like a 1. So that's the length of the tower. That's what I'm trying to find. We'll notice that, what else do we know? If this is 5.6 degrees, then remember this is a right angle from the vertical. So this is 90 minus 5.6, and so it's 84.4 degrees. And if that's 84.4 and this is 29.2, then if you add them together and subtract from 180, you get 66.4 degrees. So you need to know what those angles are, and now you can use the law of sines. So we know sine 66.4 over 105 equals sine 29.2 over L. And so now we can multiply 105 sine 29.2 divided by sine 66.4, and we get that L is approximately 55.9 meters. Okay? The next one, height of a tree. A tree on a hillside casts a shadow 215 feet down the hill. So here's the tree, here's the hill, so the shadow is along the hillside. If the angle of inclination of the hillside is 22 degrees, and they show you that part here, to the horizontal, and the angle of elevation of the sun is 52 degrees, they show you that part, find the height of the tree. So I'm going to pause this and kind of draw a new picture. Okay, so the tree is this part right here. I'm going to put T for tree. So this is what I'm trying to find. This height right here is what I need to know. So clearly, I mean, you can see this triangle right here. First of all, the part that's the shadow, which we know is 215, that's this part right here. So 215 feet is this side. We're trying to find this side. So now I need to do a little bit of work with some of these angles to figure out what we know. Well, I know that this whole thing right here is 52, the 52 degrees. Here, I'm going to mark it on here. So I know that's 52 degrees. And I know this is 22 degrees right here, which means I can figure out this part right here. So if you just take 52 degrees minus 22 degrees, so we get 30 degrees, that's this part. And that's the part we want. That's this right in here would have to be 30 degrees. So we need to know that. What else can I figure out? Well, we know that if I were to look at, let me use a different color over here. If I were to look at this triangle here, if I dropped this line straight down like that, this forms a right angle. So imagine extending the height of the tree through the ground so it forms a right angle. Now we know that this is 52 degrees. We know this is 90 degrees, which means I can figure out this. So this has to be 38 degrees, so that that whole triangle adds up to 180. Well, that corresponds to this part right here. So this is 38 degrees. Well, now I know if that's 38, actually I don't need to know. I could figure out this angle as well, but I can see right away I don't need it because I have an angle in its opposite side and then another angle and then the opposite side I'm trying to find. So I have sine 38 degrees over 215 equals sine 30 degrees over t. And then you can solve for t. So we're going to have 215 times sine 30 divided by sine 38. And I get that the tree is about 174.6 feet tall. That's a big tree. Okay. Last one I'm going to do for you. Observers at P and Q are located on the side of a hill that is inclined 32 degrees to the horizontal. So here you can see that 32 degrees to the horizontal. So there's the incline of the hill. The observer at P determines the angle of elevation to a hot air balloon to be 62 degrees. Now remember, the angle of elevation is always measured from the horizontal, so it's measured from going like this. At the same instant, the observer at Q measures the angle of elevation to the balloon to be 71 degrees. If P is 60 meters down the hill from Q, find the distance from Q to the balloon. Okay, so I'm going to take a minute and redraw this with the parts that we would want to label. Okay, so here's kind of my setup, my picture I'm going to work on. First of all, this is P right here, this is Q right here, and we know the distance between P and Q is 60 meters. So that's this distance right here, so that side we know. We are trying to find the distance from Q to the balloon. So we want to know this distance right here. So notice the triangle that I'm working with. So I have to be able to figure out a couple of these angles in my triangle so I can set up a proportion using the law of sines. So what we do know is we know that this angle right here is 32. I also know that at observer P, there's an angle of elevation of 62. Well, that's this whole thing. It's not just because it has to be measured from the horizontal. So it's this whole thing right here, and that is 62. So from geometry, I want you to remember that if you have parallel lines, which we do right here, so if you have parallel lines cut by a transversal, then the corresponding angles are congruent. So that would be this little piece here is 32 and this little piece here is 32. So if we take the 62, which was the whole thing, and subtract out the 32, we get 30, and that's the part that would be right here. I don't really have much room, so I'm going to write it out here. 30 degrees would be this angle right here. Again, remember that the whole thing, if I had drawn this whole thing, was 62, but I subtracted 32 because of the corresponding angles that were congruent. So the angle that's inside the triangle is 30 degrees. Now I'm going to do something similar over here. So at angle Q, we know that this is 71 degrees, but this little portion is also 32 because it's still corresponding. So if we take 71 minus 32, then we end up with, let's see what we had on that one. So we have 39 degrees, and so that would be this little part here. But I don't want that. That's not part of my triangle. This is part of my triangle. Well, notice there's a straight angle right there. So I need to do 180 minus 39. And when I do, I get 141 degrees. That's the angle that's inside the triangle that I want, 141 degrees. Now I have a side. Actually, I need to know this up here because I know the side that's opposite this little small angle. So I know 30 plus 141 is 171. So this right here has to be 9 degrees. So now that I have those parts there, now I can use the law of sines because I have sine of 9 degrees over the opposite side is 60 equals sine of 30 over d, which is what I'm trying to find. So if I take 60 sine 30 and divide by sine 9, I get approximately 191.8, and that would be, where are we at here? Meters. Okay, so pictures. You must show pictures. When you turn in your assignment on this, I better not see anything blank. If you don't actually carry the whole problem through to completion because you have trouble on it, I get that. Okay, these aren't easy. Some of them are complicated. But I expect to see something on your paper, some kind of picture with some things labeled. You can see it's almost, kind of like a puzzle. Identify what triangle you're working with and say, what do I know from geometry that I can figure out some of these angles or some of these sides. So good luck. You can do it.